Alright guys, so math class is tough, so here's how to go through three different problems. So our first problem is a polar graph problem, and in this problem we have to sketch the curve and find the area inside of the inner loopy for the curve by setting up the integral for the curve 1 plus 2 sine theta for 0 to 2 pi. So we're going to start by sketching the curve. First, we're going to find some points on the polar graph, and then we're going to use these points to help us mark out the curve. So we're going to start with r of 0, so theta equals 0. So you're going to have 1 plus 2 sine of 0 is going to be equal to 1, and that point is going to mark out here on our polar graph. Next, we're going to do r of pi, which is equal to 1 plus 2 sine of pi, which is equal to 1 again, and this will be marked out here on our polar graph at the angle pi. Then we're going to do r of pi over 2, and this will be 1 plus 2 sine of pi over 2, which is equal to 3, and this point will be marked out here on the polar graph. And our last point will be r of 3 pi over 2, which is equal to 1 plus 2 sine of 3 pi over 2, which is equal to negative 1. Because this r is negative, it's going to be opposite the direction it would normally be on the polar curve at the angle 3 pi over 2, and so it'll be up seemingly at pi over 2, but it's not, it's just negative. And so we know that this is an inner loop limacon not only because the question asks for the area in the next part, but also because when r is equal to a plus b of sine theta, a over b is less than 1, then the curve is an inner loop limacon, and so our curve is going to end up looking like this when we graph it out. And then part B is to find the integral inside of the inner loopy, which is this red area right here, for the curve, and we only have to set up the integral, we don't have to evaluate it. So we're going to start by setting 1 plus 2 sine theta, our r, equal to 0, because this will help us find when the curve hits the pole, where the radius is 0. So then you subtract 1 from both sides, and you have 2 sine theta equals negative 1. Then you divide by 2, you have sine theta equals negative 1/2. And then sine is equal to negative 1/2 at the angles 4 pi thirds and 5 pi thirds. So theta is equal to 4 pi over 3 and 5 pi over 3. Now, the equation for the area of a polar curve is 1/2 integral a to b of r squared d theta, as given here. And so, because our curve is moving in this direction, as indicated by the arrows, starting at angle 0 and going along the curve in the direction of the arrows, we see that first the curve hits the pole at 4 pi thirds, and then it leaves the inner loopy at 5 pi thirds. So if we are integrating from a to b, a will be 4 pi thirds and b will be 5 pi thirds, as indicated by the arrows, the red arrows pointing at the curve. So our integral for the area will be 1/2 integral a to b, 4 pi thirds to 5 pi thirds, of our r, 1 plus 2 sine theta squared d theta. The second problem is the area between two polar curves. So we have to sketch the curve and set up, again, not solve, the integral for the area of the region common to the two regions bounded by the following polar curves, r equals 4 sine 2 theta and r equals 2, in the first quadrant only. So we're going to start by sketching the curves, and for this, we're going to have the same 4 points that we had initially. So r of 0 equals 4 sine of 0, which is 0. r of pi, which equals 4 sine of 2 pi, because remember it's 4 sine 2 theta, which equals 0. r of pi over 4, so that we can get sine of pi over 2. So we have 4 sine pi over 2 equals 4. And then r of 3 pi over 4, which will give us 4 sine of 3 pi over 2, which is negative 4. And these points are marked out by the red dots on the graph, as we can see, because the radius is negative for 3 pi over 4, it goes opposite the direction of that angle on the graph. And so, because our first r here that we're solving for is 4 sine 2 theta, we know that it will be a 4-leaf rose, and this is because when you have an even coefficient in front of the theta, you double that number to get the number of petals of the rose. So we have a 2 in front of the theta in the trig function, so it'll be a 4-leaf rose, and it'll look a little something like this, with the direction of the curve indicated by the arrows. So we start at 0, go up to pi over 4, and then down to 7 pi over 4, and then over to 5 pi over 4, and then up to 3 pi over 4, and then back to 0. And our second curve is r equals 2, where the radius will be 2 all the way around for every single angle, and that just ends up being a circle. Alright, so then we have to find the area between the two curves in the first quadrant only. For this, we're going to start by looking at this red region bounded here. When we have the curves set equal to each other, we'll have 4 sine 2 theta is equal to 2, which then becomes sine 2 theta is equal to 1/2. 2 theta is equal to pi over 6, 5 pi over 6, because that's when sine of theta is equal to 1/2. So then theta is equal to pi over 12 and 5 pi over 12. Now, if we draw lines at pi over 12 and 5 pi over 12, we'll see that there's a region, there's a part of this region that's only dependent on the curves individually. So this main triangle in the center is only dependent on the curve r equals 2. And because of this, the integral will be 1/2 integral pi over 12 to 5 pi over 12 of 2 squared d theta. Now, the part on the outside, which isn't in this main triangle, that's only bounded by our rows, will be 2 times 1/2 the integral 0 to pi over 12 of 4 sine 2 theta squared d theta. Now, the reason it's 2 times this is because the region from 5 pi over 12 to pi over 2 of the 4-leaf rose is going to be symmetrical to the 0 to pi over 12 piece. So we can multiply this segment by 2 and eliminate doing 2 nasty integrals if we were to evaluate this later down the line, and the sum of these 2 integrals together is going to give us the total area between the two curves. And then our final problem is a parametric problem, where at time t, a particle moving in the xy plane is at position x of t, y of t, where x of t and y of t are not explicitly given. For t is greater than or equal to 0, dx dt equals 4t plus 1, and dy dt equals sine of t squared. At time t equals 0, x of 0 equals 0, and y of 0 equals -4. So the 3 things we have to do for this problem are to find the position of the particle at time t equals 3, find the total distance traveled by the particle over the time interval 0, 3, and find the speed of the particle at time t equals 3, and each of these problems is calculator friendly. So A, to find the position of the particle at time t equals 3, I've put our givens on the side here. You're going to start by having x of 3, which is going to be equal to 0, the initial position, t equals 0, plus integral from 0 to 3, 4t plus 1, which is dx dt. And that's going to give you 21. And then for y of 3, you're going to have initial position -4, plus integral from 0 to 3 sine t squared dt, and that's going to give you approximately -3.23. And if you were to write this in the notation given, you would have 21, -3.23. And then part B, we're going to find the total distance traveled by the particle over the time interval 0, 3. Again, put our givens on the side. So total distance is the integral of your speed, and your speed equation is going to be radical x prime of t squared plus y prime of t squared, and those will be your dx dt and your dy dt. So we're going to have the integral from 0 to 3, as that's our interval, radical 4t plus 1 squared, which is your dx dt squared, plus sine of t squared, which is your dy dt, and it's all going to be with respect to dt. And that's going to give you 21.09, and that'll be your total distance traveled over that interval. The last part is to find the speed of the particle at time t equals 3, which we kind of already talked about this, but again, I put our givens on the side, and the speed equation is radical x prime of t squared plus y prime of t squared. And so the speed at time t equals 3 is going to be equal to 4 times 3 plus 1 squared, which is going to be your dx dt at t equals 3, plus sine of 3 squared, which is going to be your dy dt at t equals 3. And that's going to be equal to 13.01. And that'll be your speed time t equals 3. Thanks for a great year, Hall. Hope you enjoyed this video.